I am Mark, virtual teacher instructor at Egnatia Career College. Today we'll teach drainage waste and vent segments and sizing. This is video number 5. Drainage waste and vent, DWV, system. Every plumbing fixture connected to a drainage system must be protected by a fitting or device known as a trap that uses a water seal to prevent harmful sewer gases from entering a building. To ensure that a drainage system does not become overpressurized and that a vacuum is not created, an adequate vent system is installed to protect a trap seal. Imagine placing your thumb over the end of a drinking straw placed in a glass of water. When the straw is removed from the glass, the water remains in the straw because a vacuum is created within the straw. When your thumb is removed, the water drains from the straw because the vacuum is broken. This illustrates the importance of having a vent system connected to the drainage system, and how airflow plays a major role in allowing water to flow by gravity. The common abbreviations for the major segments of a DWV system are BD, building drain; BS, building sewer; CO, cleanout; SV, stack vent; VS, vent stack; VTR, vent through roof; WS, waste stack. Building sewer. A building sewer is the main pipe conveying sewage and wastewater from a DWV system to a point of disposal or termination. A public sewer system and private septic tank are two common points of disposal that are legal means of termination. Codes regulate minimum sizes. There must be a cleanout serving the building sewer. A cleanout is usually installed at the beginning of a building sewer with its connection to the building drain. Some codes do not allow a building sewer to be smaller than 4-inch. Building drain. The building drain, which is the lowest horizontal portion of a drainage system, receives discharge from waste stacks and horizontal branches. It is connected with a building sewer where the cleanout is installed at the junction of the two pipes. Many codes state that it cannot extend more than 10 feet from the exterior of the building. The size of the building drain is based on the drainage load of the entire system. Minimum sizing of drains is dictated by codes. For example, some codes mandate that the smallest DWV pipe that can be buried below ground must have 2-inch diameter. Other codes allow smaller DWV pipe to be buried, but never smaller than 1 1/4 inch. Waste stack. The waste stack is the main vertical pipe, which begins with its connection to the building drain and terminates with its connection to the stack vent. It receives discharge from horizontal branches and must have a cleanout at its base. Its size is based on the total load of all connecting fixtures, and it can be offset to the horizontal position. If a waste stack is transitioned horizontally, strict codes dictate where branches can be connected to the stack in relation to the horizontal offset portion. Codes also state that a relief vent must be installed to eliminate pressure differences within the stack on certain designs. A 45 degrees offset in a waste stack is still considered to be in the vertical position. A relief vent is required if a branch is connected too close above or below the offset area on certain designs. Stack vent. The vent for the waste stack is known as the stack vent. It begins at the highest branch connection to the waste stack and is a dry piping system. It typically extends through the roof, but can connect with the vent stack prior to terminating to open air. Its size is typically based on the size of the waste stack, but in some codes the size is based on that of the building drain. If code allows its size to be reduced, it cannot be less than half the diameter of the waste stack or building drain and never less than 1 1/4 inch. Most codes dictate that the stack vent cannot be transitioned horizontally until it is 6-inch above the flood level rim of the highest fixture connecting to the waste stack. When a battery-vented horizontal branch is used, most codes allow the stack vent to serve as the required relief vent for certain designs and to receive the loop vent. Vent stack. The vent stack is the main vent of a DWV system. It receives all other vents and is a dry piping system. The term vent refers to a pipe that circulates air. Unless otherwise indicated, all vents are dry. Several piping configurations allow a drain to be used as a vent. It is known as a wet vent and is discussed later in this chapter. The size of a vent stack is based on numerous factors, including the total discharge load of a system, which is expressed as drainage fixture units, FU, and the length it travels. It can be terminated to open air or connected to the stack vent. However, it must be connected to the waste stack or building drain in a vertical position, or no greater than 45 degrees from true vertical, so it is not obstructed after a blockage in the drainage system or when moisture settles in the piping system. Some codes require a cleanout to be installed at its base. The vent stack can transition horizontally without requiring a relief vent. However, as with all horizontal vents, it must have adequate slope to prevent moisture from settling and obstructing its airway. Cleanout. All codes dictate that a cleanout must be installed at the base of every waste stack and at the transition from a building drain and building sewer. In general, a cleanout must be the same size as the pipe when it is serving a stack, building drain, or building sewer. But most codes allow any pipe greater than 4-inch to be served with a 4-inch cleanout. Exterior cleanouts in a sidewalk or driveway must be installed flush with the finished grade and must be designed to handle relevant traffic loads. Vertical piping has a DWV fitting known as a test tee or a wall cleanout. The test tee is also used to perform a water test on the system during the installation phase of construction. Minor segments of a DWV system. The minor segments are part of a fully functioning system. Even when many minor segments are not part of a design or installation, the major segments still exist. Major and minor segments are similar to a tree with branches and twigs. A tree's trunk supports its branches and twigs. A DWV system's major segments support its minor segments. The common abbreviations for the minor segments of a DWV system are BV, branch vent; CV, circuit vent; FB, fixture branch; FD, fixture drain; HB, horizontal branch; for individual vent; LV, loop vent; RV, relief vent. Fixture drain. The fixture drain serves a single fixture trap and is sized according to the individual fixture load. A fixture drain can be horizontal or vertical, but never be smaller than the minimum trap size of a fixture. Fixtures producing large loads have different drain sizing criteria. The drain size can be determined from a sizing chart in a code book. The fixture drain must have adequate slope, which is dictated by codes and its size. Many codes allow a cleanout for a low-flow fixture drain such as a sink to be smaller than the pipe. Most allow a removable joint in a trap to serve as a cleanout for a 1 to 1/4 inch through 2-inch fixture drain. Because a toilet can be a point of access to the drain, the toilet can also serve as a cleanout for its fixture drain, and allowable by some codes to serve its fixture branch. In addition, a floor or shower drain with a removable strainer can serve as a cleanout for its fixture drain. Fixture branch. The fixture branch is a drain pipe that connects 2 or more fixture drains to a horizontal branch or major segment of a DWV system. It can also be called a horizontal branch because it could potentially connect to a major segment such as a stack or building drain depending on the specific design of the system. Its position can be vertical or horizontal. Its size is based on the total load of all the fixtures it serves and on whether it is vertical or horizontal. It must have adequate slope, which is dictated by codes and its size. It must be served with a full-size cleanout, but some codes allow a pipe greater than 4-inch to be served with a 4-inch cleanout. Some codes do not allow a fixture drain to serve as a cleanout for a fixture branch. Other codes allow a toilet to be considered a cleanout access point for the fixture branch serving that toilet. Horizontal branch. As its name indicates, the horizontal branch is a drain pipe that is connected horizontally to a major segment of a DWV system. It can be connected either to a waste stack or to a building drain. It connects 2 or more fixture drains or a fixture branch to a main segment of a DWV system. Its size is based on the total load of all the fixtures it serves. Some codes allow a maximum of 2 toilets on a 3-inch horizontal branch, but some codes allow more. Special regulations must be followed for a battery-vented horizontal branch. Typically, it can serve only 50% of the drainage load of a standard horizontal branch. It must be served with a full-size cleanout, but some codes allow a pipe greater than 4 inches to be served with a 4-inch cleanout. Because it is a drain, it must have adequate slope, dictated by codes and its size. Battery venting designs are more relevant in commercial design than residential. Individual vent. An individual vent is by definition a vertical extension of a drain that serves one fixture trap. It can be connected to other vents or terminated to open air. A piping arrangement known as a common vent allows it to serve two fixtures that are located on the same floor that connect to the same vertical drain. Another piping configuration that might not be allowed by some codes is a wet vent. It uses an individual vent for numerous fixtures. Some code books indicate that an individual vent can also be a branch vent. This is because an individual vent serving one drain that is connected directly to a waste stack is essentially a branch vent. It must be at least half the diameter of the drain it serves, but no smaller than 1 1/4 inch. Branch vent. When two individual vents are connected together, they form a branch vent that serves as a vent for a horizontal branch and is connected to the vent stack or stack vent. The size of a branch vent is based on the size and drainage load of the horizontal branch and the distance it travels. A vent must have adequate slope to drain condensation or moisture, but is not typically regulated like a drain regarding minimum fall per foot. A circuit vent and a loop vent are also branch vents, but their specific sizing requirements differ from those of a standard branch vent. Circuit vent. A circuit vent is a branch vent, but it is different from other standard branch vents and has specific code requirements. It serves a drainage piping arrangement known as a battery of fixtures. A relief vent must accompany a circuit vent to complete the battery vented system. Single-family residential constructions usually do not have battery configurations due to the small number of fixtures located within one room. Commercial plumbing installations frequently use batteries of fixtures in large bathroom areas. Circuit vent sizing is based on the horizontal branch size, fixture load, and distance it travels. It is typically connected vertically to a horizontal branch before the last fixture, and it terminates to the vent stack. A circuit vent is also known as a loop vent when it is located on the top floor of a building or at the highest branch interval. Most plumbing license exams have questions about circuit venting. Loop vent. A loop vent is a circuit vent that is installed on the top floor of a building or on the highest branch interval of a battery-vented branch. Most codes do not require a relief vent to serve a loop-vented horizontal branch because it loops back and connects to the stack vent instead of the vent stack. No other fixtures discharge into a stack vent above a loop vent connection. Because the waste stack no longer exists on the top floor, the loop vent can be connected to the stack vent instead of the vent stack. All sizing in code regulations are the same as those for a circuit vent. Some codes still require a relief vent on a loop-vented branch if more than 3 toilets are connected to the horizontal branch. Relief vent. Many types of relief vents exist in a DWV system, all with different regulating codes. A relief vent is required when a waste stack transitions from vertical to horizontal on many designs. The most common relief vent is one that serves a battery of fixtures. It is connected to the circuit vent before the first fixture. Many codes mandate that a relief vent must be installed when a venting device known as an air admittance valve, AAV, is installed to serve a horizontal branch. A relief vent used on buildings more than 10 stories tall is a yoke vent that connects the waste stack and stack vent to equalize pressures within the waste stack. A relief vent serving a battery of fixtures is half the diameter of the horizontal branch. All relief vent sizes are based on their specific use and are determined by using a code book, but they cannot be less than half the diameter of the drain they serve and no smaller than 1 1/4 inch. Special venting arrangements. Special venting arrangements are used when conventional methods do not work. Wet venting. Wet venting is a piping arrangement that uses a single vent for more than one fixture. It is not accepted by all codes. Some designs would be difficult, if not impossible, if all fixtures within the design had to be individually vented. Using a wet vented system can offer a solution to design situations that would seem impossible with only utilizing dry vents. A single-occupancy bathroom is commonly wet-vented. In a typical residential bathroom consisting of a toilet, lavatory sink, and bathtub, the likelihood of all fixtures being used at the same time is minimal. A single vent can serve the bathroom group, with the initial size being based on the largest pipe of that group. A chart in a code book is used to size the wet-vented portion of the drain according to the actual fixtures and their DFU values. Wet venting arrangements for this type of installation are common where codes allow wet venting and do not require approval by a code official. Specific sizing must adhere to codes based on the total drainage load and the wet vent size. One code that typically remains the same for a wet vent arrangement is that any fixture downstream of a toilet usually has been individually vented. Combination waste and vent. The two types of combination waste and vent systems are vertical and horizontal. Both are sized based on their installation position and the drainage load they serve. Only specific fixtures can discharge into this type of system. Codes dictate the fixture type and drainage load that can be handled by a certain pipe size. The vertical design is used for typical low-volume fixtures such as an electric water cooler or floor drains that are directly above one another on several floors of a building. The vertical waste stack is also the vent, and because a separate vent stack is not required, the stack is classified as a wet vent. It still has a stack vent similar to a conventional waste stack and must have a cleanout at the base of the stack. It cannot be offset horizontally or vertically throughout the entire developed length of the pipe route. Code limits the distance a trap can be located from the vertical stack based on the size of the fixture drain. A horizontal combination waste and vent system has stricter regulations than a vertical design. This design is most common in large commercial kitchens and manufacturing plants where there are not enough available walls to install numerous vents. The size and type of fixtures that can be connected to this kind of system are strictly regulated and listed in a code book. Slope is required and dictated by codes because this system is in the horizontal position and often cannot slope more than 1/4 inch per foot, regardless of the pipe size. The distance a trap can be located from the horizontal branch is limited and dictated by codes based on the size of the fixture drain. This distance of the trap from the horizontal drain is known as the trap distance and is the same distance allowable as for conventional drainage and vent systems discussed earlier in this chapter. Most plumbing license exams contain questions about combination waste and vent systems. Island venting. A kitchen sink located away from a wall can usually be served with an island vent. An AAV can be used instead of an island vent, but it might not be allowed by some codes or areas of installation. Code dictates that a dry vent cannot be transitioned horizontally until it is 6 inches above the flood level rim of a fixture. Therefore, an island vent arrangement is strictly regulated because a portion of the vent is placed horizontally below the flood level rim of the fixture. The vent located under a sink can be transitioned horizontally below the flood level of the sink, but the vertical portion away from the sink that rises in a designated location cannot be transitioned horizontally until it is 6 inches above the flood level rim of the sink. This design might need to be submitted to a code official before it can be installed. DWV sizing. Layout for a DWV system is typically the first process completed on a project. Other piping systems are installed around it. Pipe and fitting sizes of DWV systems are larger than those of other piping systems in a residential building, and code regulations, specific fixture locations, and available space to install piping make it necessary to install or lay it out first. Layout is based on objectives, codes, and sizing requirements. Sizing of piping is initially based on theory, but health issues combined with practical considerations determine how codes actually regulate the sizing of a DWV system. Sizing is a key area that a plumber must understand to become licensed. Theoretical methods that determine sizing are based on the rate of flow at which a fixture discharges wastewater into a drainage system. The measuring factor is a DFU. The average plumber does not perform calculations on a job site, but instead uses the known DFU values of fixtures to locate correct sizing information in a code book. Most DFU values listed in a code book are based on the flow rates of certain fixtures, pipe sizes, and the DFU load effects on a DWV system. All horizontal drains must have adequate slope, also called fall or pitch, to evacuate wastewater and solids. Minimum pipe slope is based on the pipe size. Too much slope on a waste arm serving a fixture can place the trap where above the center of the connecting vent, causing air to be trapped in the waste arm. Trapped air in a waste arm can cause a sluggish drain and a gurgling noise. Charts in a code book list minimum slope for different pipe sizes, and many charts have options for additional TFUS to be served if more slope than the minimum standard is provided. Note that the footnote indicating the UPC allows for a plumber to seek approval to install pipe at 1/8 inch per foot slope on 4 inch and larger. A separate chart in a code book shows where an installation occurs based on the segment of a system. A different chart is needed if a drain is connected to a building drain than if it is connected to a waste stack. A vertical pipe, such as a waste stack, can evacuate wastewater and sewage faster than a horizontal pipe, such as a building drain. Codes have a practical basis for determining the sizing, but vary according to the particular segment of a DWV system being sized. Figure shows IPC version of building drain, building sewer, and branch sizing chart. The IPC sizes horizontal branches or fixture drains based on whether they are connected to a waste stack or building drain. Note that pipe sizes from 1 1/4 inch to 2.5 inch do not have options to install pipe at 1/16 inch or 1/8 inch per foot slope. This figure relate to branches in different intervals of a waste stack, because it is concerned with horizontal branches connecting to a vertical stack. The UPC uses a completely different type of sizing chart. The UPC combines horizontal and vertical piping within a single table, while the IPC has two separate tables. UPC indicates that the allowable DFUS can be served by a specific pipe size. It also indicates the maximum length a pipe size can be installed serving the DFU load. One unique aspect of the UPC method is it includes the allowable unit load and distance of vents within the same table as the drainage information. IPC sizing in code issues for a waste stack that is offset horizontally are explained in this picture. Fixture drain sizing. A fixture drain installed above ground is sized according to the particular fixture served. A code book indicates the minimum drain and trap size that can serve a particular fixture. Actual piping location can change the minimum size listed in a chart for a drain, especially when DWV piping is installed below ground. Although a drain cannot be smaller than 1 1/4 inch in diameter, most codes dictate that the smallest drain that can be buried below ground is 2 inch in diameter. This illustrates that sizing is not always based on DFU theory, but can also be based on practical experience. A separate drain cleanout serving a fixture drain is not required if the drain can be accessed with a removable slip joint connecting the trap to the drain. Because a toilet and a urinal are removable, they can serve as a cleanout for the fixture drain. A fixture drain must have an equal size cleanout with the exception of a 1.5 inch trap adapter that can serve a 2 inch fixture drain, and a 1 1/4 inch trap adapter that can serve a 1.5 inch fixture drain. These sizes are acceptable by most codes. Fixture branch and horizontal branch sizing. A fixture branch and a horizontal branch are often categorized as the same pipe, depending on the complexity of a piping configuration. From a sizing standpoint, they use the same approach, which is to calculate the DFU load the branch serves. Some branches are connected to a waste stack and some to a building drain. Unlike a fixture drain, the branches require a designated cleanout and cannot be served by removing a fixture or trap. However, code officials might allow a fixture to serve as a cleanout for similar configurations as long as the fixture branch is not larger than the fixture drain size. If the fixture drain is 1.5 inch and the fixture branch is 2 inch, an official might still allow the fixture as a point of access to the drain. Cleanouts are installed in various locations in a system. The maximum allowable distance between them is dictated in a codebook, but they typically cannot be more than 100 feet apart. Waste stack sizing. Most charts have several columns for different building designs, including a single branch interval, a 2 or 3 branch interval, and a column for more than 3 intervals. Some codes allow a waste stack to become smaller when it travels up higher a building, but it can never be less than half the diameter of the base of the stack. Because various configurations exist on construction sites, and a waste stack is a major artery of a DWV system, a chart can provide only general sizing information. Offsets in a waste stack are required on many projects, and the offset areas are regulated with additional codes. In some designs, a waste stack transitioning greater than 45 degrees from true vertical may have special regulations used to size the waste stack. Some codes state that any connections occurring within the offset area or dedicated protected zone within the offset area, the waste stack can no longer be sized from a chart. Many codes do not allow any connections within the horizontal offset area or protected zone if more than 4 branch intervals are located above the offset. A vertical offset in a waste stack is considered to be 45 degrees or less from true vertical. A relief vent is not required on a vertical offset unless there are more than 4 branch intervals above the offset area. If a relief vent is required, the upper and lower portions of the offset area must be vented separately, and the relief vent for the lower portion is connected to the vent stack. The stack vent vents the upper portion of the offset waste stack. One allowable way to avoid installing a relief vent is to size the entire stack, including the offset area, based on building drain regulations, which essentially means oversizing the stack. A code book has regulations and possibly illustrations pertaining to offsets in a waste stack, many of which require the installation of a relief vent horizontally. A cleanout must be installed at the base of a waste stack. Some codes might dictate that the base of a stack cleanout must be installed above the highest fixture located on the floor where the cleanout is installed. Building drain and sewer sizing. IPC sizing methods for a building drain and the importance of calculating ALDFUS that it evacuates. Because a building drain is a major segment and the lowest horizontal portion of a DWV system, it has additional codes to adjust to variations in a project design. A chart lists general sizing scenarios, but additional codes are needed for unique situations that occur during the design or construction phase of a project. The building drain and building sewer are 2 different segments of a system. Some codes may allow different testing requirements for a building sewer than for a building drain, because the sewer is outside the building and can typically be excavated if problems arise in the future. Most codes require a more rigid pipe specification for a building drain than for a building sewer, because it is within the footprint of the building, often making it more difficult to replace. Because a vent stack can originate from its connection to a building drain, certain codes regulate the connection point to make sure that the vent stack is not affected by the turbulence created when the waste stack discharge enters the building drain. If a vent stack originates at the building drain, the connection must be no farther than 10 pipe diameters from where the waste stack is connected to the building drain. A vent stack that is connected to a building drain must be installed in the vertical position. If the building drain is located underground, most codes dictate that it must be at least 2 inches in diameter even though the IPC chart. The smaller sizes are typically relevant only when the building drain is installed above ground. Most codes dictate that the smallest building sewer must be 4 inches, the building drain can be smaller than the building sewer. According to some codes, the base of a stack cleanout on a 3-inch minimum size waste stack can be used as the cleanout for the building sewer if it is located not more than a developed length of 10 feet from the junction of the building drain and sewer. Stack vent and vent stack sizing. Many codes dictate that a stack vent must be the same size as the waste stack. Other codes dictate that a stack vent and vent stack must be sized by the length they travel and the total DFUS they are responsible for discharging. In addition, they cannot be less than half the diameter of the waste stack or less than 1¼ inch. A vent stack, which receives vents from a DWV system, can originate in the vertical position from either the waste stack or the building drain. The IPC chart for sizing a stack vent is usually the same one used for the vent stack. A horizontal branch that is connected to a building drain does not have to be calculated in the sizing of the waste stack. However, its DFU value does have to be considered in sizing a vent stack if the vent for that same horizontal branch is connected to the vent stack. This results in different sizing approaches for a vent stack and a stack vent concerning the DFUS connected to each segment. If vents serving a horizontal drain that is connected to a building drain are routed to areas other than the vent stack, the DFUS of that drain do not have to be considered in the total vent stack DFU value. If a vent stack and a stack vent are connected before terminating to open air, the larger of the two must be used for sizing the roof penetration, and the size must accommodate the stack with the greater DFU value. In colder climates, the minimum size allowable for a roof penetration must be confirmed on a chart showing frost closure codes. Individual vent sizing. An individual vent is generally half the diameter of the drain it serves, but no less than 1¼ inches diameter. Some codes dictate that a vent must be increased. One pipe size if it travels more than 40 feet or other distances dictated in a code book, and that the increased size begins from its point of origin with the drain. A piping configuration that can be served by an individual vent is a common vented piping arrangement. When two fixture drains are located on the same floor and are connected at the same height or at different heights to the same vertical drain, it is vented with an individual vent. The dry portion of a common vent is sized the same as an individual vent. If the two fixtures are connected at different heights to the same vertical drain, the middle section is a wet vent. The middle section is sized using a different chart in a code book from the chart used to size the individual vent. Specific regulations exist pertaining to common venting. A toilet cannot be the fixture using the top drain, and the DFU value of the upper fixture must comply with a chart in a code book based on the pipe size of the wet vent. The IPC has a designated chart for common venting sizing and DFU load, but the UPC does not. The UPC identifies the regulations as vertical wet venting and does not allow less than 2-inch pipe to be used. Branch vent sizing. A branch vent is sized by the diameter of the drainage branch, the DFU value it is responsible for discharging, and the length it travels. A branch vent cannot be less than half the diameter of the drain it serves, and no less than 1¼ inch diameter. Some codes dictate that a branch vent must be increased one pipe size if it travels more than 40 feet or other distances dictated in a code book, and that the increased pipe size must begin at its connection to the horizontal branch. Some codes dictate that a branch vent must be increased one pipe size when two individual vents are connected to form the branch vent. For example, if two 1½ inch individual vents are connected to form the branch vent, it must be at least 2 inch in diameter. Circuit and loop vent sizing. Both a circuit and a loop vent are classified as branch vents, but they are special piping arrangements that must be sized according to their unique piping allowances. The term circuit refers to isolating a portion of a DWV system to create its own little system. It makes its own air circulating circuit from other segments, even though the drain and vent are connected to the same main segments as other branches do. Most codes dictate that any fixture located downstream of a toilet must be individually vented. However, most codes allow for numerous fixtures to be piped in a battery. A toilet can be downstream of another toilet when it is installed in a battery-vented configuration served by a circuit or loop vent, but it must adhere to numerous regulations. The horizontal battery-vented branch is sized based on the total DFUS it serves and must be piped full-size throughout its length. Most codes dictate that no more than 8 fixtures can be connected to a battery-vented horizontal branch. If more than 8 are connected, the excess fixtures must be individually vented. A circuit vent begins in front of the last fixture connected to the horizontal branch and terminates with the vent stack. A code book may have a vent sizing chart for sizing a circuit or loop vent, and codes might limit the distance it travels based on a pipe size of the vent. A relief vent is required on a battery-vented branch served with a circuit vent. A loop vent is the same as a circuit vent except that it does not require a relief vent. However, some codes dictate that a relief vent must be installed if more than 3 toilets are connected to a battery-vented branch. The loop vent is still connected in front of the last fixture of the horizontal branch, but it is connected to the stack vent instead of the vent stack. Some codes dictate that a relief vent for a battery-vented branch must be at least half the diameter of the horizontal branch, but no less than 1.5 inch diameter. This varies from other vents that cannot be smaller than 1.25 inch diameter. Wet vent sizing. One regulation that typically remains in effect even when installing wet vented piping arrangement is that no fixture can be installed downstream of a toilet without being individually vented. If a toilet is one of the fixtures within a wet vented configuration, the minimum size of the dry vent is 1.5 inch because a vent must be at least half the diameter of the drain it serves. The reasoning behind this vent sizing is that a toilet must have at least a 3-inch diameter drain. That step in the process established only the dry vent portion of the bathroom group. The size of the wet vented portion is based on the DFU value of the fixture or fixtures draining into the wet vent. A chart in a code book usually lists the allowable number of DFUs that can drain into a particular size wet vent. Any fixtures or branches that are not part of the wet venting arrangement must be connected downstream of the wet vented configuration. Air admittance valve sizing. AAVs allow air into a DWV system but do not allow sewer gas to escape into an occupied area. They were initially introduced for use under a kitchen sink or in remote areas where it is difficult to install individual vents. A stack vent must terminate to open air and cannot be served by an AAV. Many codes require a relief vent on a horizontal branch served with an AAV. Remember that a horizontal branch is a DWV pipe that serves 2 or more fixtures, so a relief vent is not required for a fixture drain that is served with an AAV. This type of relief vent differs from those described for offsets in waste stacks and for battery-vented branches. AAV sizing is based on the size of a vent using the same codes as those for individual and branch vents. If the AAV is installed on an individual vent, the pipe size and the AAV selection would be determined. AAV sizing is based on the size of a vent using the same codes as those for individual and branch vents. If the AAV is installed on an individual vent, the pipe size and the AAV selection would be determined and would need to comply with all codes for an individual vent. Some codes dictate that only a certain number of TFUs can be served with a particular size of AAV. A chart in a codebook is used for sizing based on the DFU the AAV serves. An AAV cannot be installed in supply or return HVAC air plenums or be used in certain specialty DWV systems such as acid neutralization systems. Access must be provided to replace an AAV. Wall boxes with louvered access covers are sold for this purpose. The AAV must be in an area where there is adequate air to enter a DWV system through it. The height above the trap and above the insulation in an attic is regulated. Island vent sizing. A sink located away from walls is a candidate for being served with an AAV, but if they are not allowed by codes, the sink can be piped with a special venting arrangement known as an island vent. Most special DWV designs must receive approval from code officials before installation can begin. Most codes limit island venting to sinks and lavatories, which includes dishwashers and garbage disposals when used for a kitchen sink installation. If an island vent is installed on a bottom floor and the pipe is installed underground, most codes dictate that a below-ground DWV pipe must be at least 2 inches diameter. If the island vent pipe is no installed below ground, drain and vent sizing is based on codes for standard fixtures. A full-size cleanout must be installed to serve the lowest portion of an island vent under the sink. The island vent piping must be installed vertically as high as possible under the sink before it is transitioned horizontally. All fittings used in the vent piping below the flood level rim of the fixture must comply with drainage codes for their flow patterns. The island vent under the sink must be a vertical continuation of the fixture drain, and the fixture drain must be connected on the top half of a horizontal drain. Vertical means that a pipe is in the true vertical position or no more than 45 degrees from true vertical. Trap distance. An important layout consideration based on DWV codes is the location of a fixture trap in relation to its protective vent. Codes that regulate the maximum distance a trap can be located from a vent trap distance are based on the size of the drain and trap. The trap distance is determined along the pipe route as opposed to simply measuring the distance from the vent to the center of a fixture, known as developed length. A code book has a chart indicating the maximum distance. The IPC and UPC differ pertaining to the trap distances. The IPC allows for greater distances on all pipe sizes, while the UPC limits distances and also does not allow for this chart to relate to a water closet toilet. The horizontal fixture drain extending from the vent to the trap is also known as a waste arm, trap arm. Some codes regulate the maximum vertical distance a trap weir can be from the center line of the connecting vent fitting. This distance, known as hydraulic gradient, depends on the slope of the waste arm. Some codes dictate that the total vertical rise of the waste arm cannot exceed the diameter of one pipe size of the waste arm. For example, a 1½ inch waste arm cannot rise more than 1½ inch from the center of the vent fitting to the trap weir. The closest a trap can be located to a vent is also regulated. That code is known as crown venting. The weir of a trap cannot be less than 2 pipe diameters from the connecting vent, that is, a 2-inch trap weir cannot be less than 4 inches from the inlet of a vent fitting. Septic systems. Areas that are not incorporated into a city or other formal municipality use private sewage disposal systems. The one in picture is conventional gravity septic tank system.